All right, boys and girls, welcome back to the drive-through. Hope everyone's having a wonderful week. This is 5.5, Properties of Quadrilaterals. There are more facts in this section than any other section for the entire year, okay? So it's very important that you do not try to memorize these things. You should not try to memorize them. You have no chance, okay? If you understand how these definitions are nested within each other, you will minimize the amount of stuff that you have to memorize. Also, if you draw good pictures, you will intuitively remember many of these properties, okay? So we're going to start with the first, and that's properties of parallelograms. Okay, so if you're trying to keep up with notes, you might have to pause the video. Otherwise, you can also refer to your book. Okay, in your proof, you're going to be stating these in if-then form. So you would, for instance, what's the definition of a parallelogram? A quadrilateral with two pairs of parallel sides, okay, or opposite parallel sides. The definition says nothing about congruent segments. It doesn't say anything about opposite sides being congruent. So you really couldn't have used that on yesterday's test, on yesterday's quiz, just so you know. Okay? Now we learn about the properties, and on your proofs, if you want to use the properties, you just use an if-then statement. So you would say, for instance, if parallelogram, then opposite sides congruent. So that is our first property of parallelograms. So we're just going to list them. Okay? Opposite sides are congruent. What's another property of parallelogram? Well, that's not a property, that's a definition. That's within the definition. Shinya? Excellent. Opposite angles are congruent. Another one. The diagonals bisect each other. I don't know why I capitalized those. Just feeling capitalistic. Consecutive angles are supplementary. Okay? So those are the four new ones. Now, here's what I mean. If you draw yourself a good picture, now, make sure when you draw your parallelogram that you do not draw a rhombus, because if you accidentally draw a rhombus, then you're going to draw some improper conclusions. I hope that makes sense. So notice that I've clearly not made this thing so that the top side was the same length as the left side. Does that make sense? Can you notice that opposite sides are congruent? You can't notice that? I hope you can. Do you notice that opposite angles are congruent? That was what you were tasked with proving yesterday. Okay? Some of you did it in 5 steps. It was very, very good. Much shorter than I did. Okay? All right, now let's look at the diagonals. We'll have one of them in blue and one of them in red. Are these two diagonals the same length? They are not. The red one goes further left than the blue one, does it not? And it also goes further right than the blue one, does it not? So which one of these diagonals is longer? The red one. So don't tell me they're congruent. Crazy, huh? They look congruent. It's because there is some symmetry involved, but they are not. So, what's going on in this? Well, if you notice, this triangle on the left appears to be congruent to this triangle on the right. Do you see that? Do you see the vertical angles? Okay? Another way we could do it is, could you see the angle side angle. Could you see that? So you could, in your head, kind of prove that those triangles are congruent. So here's what's congruent. This segment is congruent to this segment, and this segment is congruent to this segment. Do you follow that now? And which one of these bulleted properties represents that? Number 3, the diagonals bisect each other. Cool? Okay, now we're going to go back to our chart real quick. So, we had the quads. What was below the quads? How many kids? 3. Okay, yes, general quad. We had 3. What were they? Trapezoid, pigram, parallelogram, and kiite. Okay? Now, which one of those had kids? Pigram and trapezoid. Trapezoid had an isosceles trap queen. Pigram, who did pigram have? Rectangle and rhombus. Did kiite have a kid? Not that we know of. Okay? And then, who had a grandkid? No, they had a kid. Who had a grandkid? Pigram did. It was weird. Oops, sorry. And that was square. And we are not going to go into detail. And things were different back then. Okay? Alright, so, look. Everything we just learned about a parallelogram is true for a rectangle. Everything. Are the opposite sides congruent? Are the opposite angles congruent? Are the consecutive angles supplementary? And do the diagonals bisect each other? Yes, they're all true. So you can't forget those because they're all true for a rectangle. Okay, does that make sense? So what we're going to do today to start is we're going to stay within this family right here. All right, so now let's do properties of a rectangle. The first thing that we're going to write is that all properties of parallelograms are also true. Okay? So which ones are new?
All angles are right angles.
Okay? All angles are right angles.
And then the diagonals are congruent.
Excellent. Diagonals are now congruent. That's it. That's all the new ones. Does that make sense? Again, if you have a decent proof game, you don't have to memorize any of these. I would hope that if you forgot that the diagonals of a rectangle were congruent, I would hope that you could just draw a picture similar to this, and you'd be like, those things look congruent to me. Do the blue and the black lines look congruent to you? Okay? But maybe you're like, well, I don't want to assume anything in life because Mr. Yulin tells me not to, which is good. So then you should be able to prove that, very easily that this triangle here is congruent to the white triangle. The right triangle? Yes, but I said the white triangle. You get it?
Yeah, I get it.
Okay? So, this triangle is congruent to, well, whichever other right triangle I want. We could prove it congruent to that triangle by the properties of parallelograms. Got it? Okay? Alright, so that's what we're doing today. I'm not going to keep drawing out all these pictures. You follow? Sam? What are we going to do next, Sam? What do you think? Properties of? No. Why would you listen to everybody else, Sam? Speak for yourself. You're a smart kid. Properties of? Rhombi or rhombuses. Okay? Alright. 1. Are all properties of rectangles true for a rhombus? No, a rhombus is not a rectangle. All properties of parallelograms are true. What else we got? Yes. Diagonals are perpendicular bisectors of each other. That's a big one. All sides are congruent. That's by the definition, but we'll include those.
Diagonals bisect the angles.
Big. The diagonals bisect the angles.
Divide the rhombus into four congruent right triangles. The diagonals.
Okay. When both diagonals are drawn, four congruent right triangles are formed. Here's a good way to start. Here's a good way to draw a rhombus. Start with two segments that perpendicularly bisect each other. Does that look true? Does that look like that's a perfect little perpendicular bisector cross? Well, then from there, you have to have a rhombus. So that means all four of these pink lines have to be congruent by side angle side. And CPCTC. Huh. Got it? Do you understand that this fifth property actually sums up all the rest of them? Do you get that? If you can just remember that fifth property, you know all of them. You know that these angles are congruent by CPCTC. You know that these sides are congruent and these sides are congruent, okay, by CPCTC. You know that all four of these angles are right angles by ARAT. Got it? All right, what are we going to do next, class? Squares. Properties of squares. 1. All properties of
Rectangle.
2. All
Properties of rhombus.
properties of rhombi. And then 3. 4 isosceles, isosceles, right triangles are formed when both diagonals are drawn. So we'll show you that one. What do you think? I could cheat and use my square tool, but I'm not going to do that to you guys. I'll buy it. I'll buy that to square. Isosceles right triangles. Okay? So, hold on. What does that mean? What's the measure of this angle right here? I didn't ask you what it was equal to. What's the measure of it?
45.
It is 45 degrees. Right? Because what are these angles in the middle?
Right, 90.
They're all 90 degrees. And we just said this was isosceles. So how does this angle relate to this angle? They're congruent, so they've got to add up to be 90. So what's 90 divided by 2? 45. So those are called 45, 45, 90 triangles, and we're going to have a whole section about those later. Got it? So far, so good? Do you understand what I was saying when I told you not to memorize these? The other thing is, if you memorize them, you're going to have to re-memorize them for the test. Then you're going to have to re-memorize them for the exam. Then you're going to forget them on your ACT. That was the ACT. I don't know if that was ACT or SAT. It was kind of a blend. Okay? If you just understand these things, they will be your property for the rest of your life, and you'll always remember them. And then you can use your precious brain space to memorize other things, like things about me, or maybe memories of this class that you can hold on to dearly. And those are way more valuable than stupid quadrilateral facts. Got it? All right, next. What's next now? Yep, we got a couple more to go, so we can do kites. Properties of quites. Okay. I know that the diagonals are perpendicular because that's what makes the kite fly. All properties are quadrilaterals. They don't really have properties.
One diagonal is the perpendicular bisector.
Yep. One diagonal is the perpendicular bisector of the other. You will need to remember your perp bisector theorem to remember which one is being bisected. We'll take a look at that picture. What else is true?
One of the diagonals bisects a pair of opposite angles.
One diagonal bisects a pair of opposite angles. One pair of opposite angles are congruent. Is that right? Is that on there? And one set of congruent triangles are formed by the diagonals, or by the diagonal. All right, here, I'll help you with this one. We definitely need a picture for kites, okay? Now, when you draw your picture, make sure that it is really obvious that you don't draw a rhombus, or else you're going to get it confused. So, do you see that my figure is certainly a kite and not a rhombus? Now, it'll be easy. Which of these diagonals, the red one or the black one, which of these diagonals divides the kite into congruent triangles? Is it the red one?
Yeah.
Yes, it is. It is not the black one. You see how easy that is? So now that you know the red one divides the kite by what's an easy way to prove that red one divides the kite into two congruent triangles? What method would we use? Side, 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 right? You can see it right there. Pink, blue, red, pink, blue, red, bam, congruent. Got it? So now we know all sorts of things. Do you remember the perpendicular bisector theorem? Do you remember the kite method? There were three methods: kite, Star Trek, and isosceles triangles. Well, this is just the kite method again. Again, if you memorized that the first time, now you got to memorize it again. I hope that you just understood it the first time. Okay? So look, which diagonal bisects which one? Does the red one bisect the black one, or does the black one bisect the red one? The red one bisects the black one. Which diagonal bisects angles? The red one bisects the angles. Okay? Told you, more facts today than any other section all year. Is that a true statement? All right, what are we going on to next? Trapezoids. Now, well, first we're going to start with trapezoids. All right, trap queens.
Bases are parallel.
bases are parallel. What else?
These are all isosceles.
That's it. That's all we get, right?
Yeah.
So, we could say angles on the same side of the bases, no, on the same side of the legs are supplementary. That's just same side interior angles are supplementary. You understand that? So if I gave you a trapezoid, angle 1 is supplementary to angle 2. You got that? And angle 3 is supplementary to angle 4 because of same side interior angles. You got that? Okay. The last piece here. Properties of isosceles trapezoids. Alright, there's a lot of these. Legs are congruent by definition.
Should we say all properties of trapezoids?
Yep. All properties of trapezoids are true.
Their lower base angles are congruent, and then upper base angles.
Lower and upper base angles are congruent.
And diagonals are congruent.
Diagonals are congruent.
Yeah, and then any lower base angle is supplementary to any upper base angle.
Okay. Oh, geez. Alright, so if that's an isosceles trapezoid, which segments are congruent? The blue ones are the legs. Good. Which ones are parallel? The black ones. Those are called the bases. How does angle 1 relate to angle 3? It is supplementary. Do you see that? 1 is supplementary to 2. But 2 is the same thing as 3. Therefore, 1 is supplementary to 3 by substitution. We good? I've hit my limit. I will not make a video longer than 23 minutes. Sorry, longer than 24 minutes. Okay? So now we got to get to work. I'll put your homework up. We ready? Can I get a nice healthy Tuesday boom?